Bismillahirrahmanirrahim. Today our lecture is about Exergy calculations using Aspen Plus software. So first of all, we want to know what is Exergy. Exergy is the most important concept which is used in a chemical process. It is used to evaluate the performance of a chemical process. It is consisting of following parts: chemical exergy, physical exergy, kinetic exergy, and potential exergy. We will calculate chemical exergy and physical exergy. So we will use these following formulas to calculate physical exergy, chemical exergy, percentage, exergy efficiency, exergy destruction. If we see physical exergy's formula, here H is enthalpy of a stream at given condition, H naught enthalpy of a stream reference condition, T is reference, T naught is reference temperature, S minus S naught is entropy. Here in chemical exergy, Xi is a mole fraction, ECHI standard chemical exergy of a component, R is ideal gas constant, T naught is reference temperature. So exergy efficiency is total exergy out divided by total exergy in. Exergy destruction is calculated by total exergy in minus total exergy out. Here we taking an example of heat exchangers to calculate exergy. Here we have a hot inlet, hot outlet, cold inlet, and cold outlet in a heat exchangers. Temperatures, vapors of hot inlet V is equal to 1, pressure of a hot inlet 5, flow rate of a hot inlet 100, and composition is 1. Hot outlet temperatures 2, we will find pressure is 4.9 because 0.1 is error, and pressure flow rate is 100 and composition is 1. Cold outlet temperature is 25 degrees C, pressure is 5, flow rate is 200, composition is 1. Cold outlet temperature is 35, pressure is 4.8 because error in pressure, so flow rate is 200 and composition is 1. So now we move toward Aspen Plus, putting components, choosing methods, and going in simulation environment to calculate exergy. Here we add components, water, then choosing method, clicking on method. Here choosing method, filter is all, and base method is stream NBS. Then click on run. So here we see no error is showing us Aspen. So now we move toward a simulation environment. We are also knowing we here taking example of heat exchanger. So here we take a heat exchanger, resize it. We do these quickly, giving him the material streams. Okay, right here heat exchanger. This is our hot in, this is our H out, cold in, cold out. So this is our hot in. Now here first we specify hot inlet. So, okay, we clicking on vapor fractions. Pressure we also know 5 atm, vapor fraction is 1, total mole, flow rate 100, and component composition is 1. Okay, we go main flow and specify operating conditions of cold inlet, temperature. Oh, okay, mole flow, mole fraction. Okay, cold inlet 25 degrees C, 5 temperature is 25, pressure is 5 atm, 5 atm, mole flow, molar fraction. Okay, connect 1. and 200. Okay, see here blue mark. Now we go toward main flow sheet and specify heat exchangers. Data about cold outlet stream. So we here click on cold outlet stream. The specifications temperature here 35 degrees Celsius, and minimum approach is 10 degrees C, and pressure drop of hot side 0 minus 0.1 minus 0.1, and cold side is minus 0.2. So now we go back and run the process. Click on home and run the process. Okay, here we see no error results are available, but now we simulated the process, which is the main requirement, and going for Exergy analysis. First here we see stream results. Okay, all results are available, but here we see no Exergy flow rates are available. For this you did go to setup and click on calculation options. Here you should specify Exergy reference environment temperature and Exergy reference environment pressure. Here we have temperature is 25 degrees Celsius and pressure is 1 atm. Then you did go to back in a stream results, and here you see no Exergy calculation is available. Now we click on Exergy, click Exergy, click OK. Okay, Exergy flow rate is available. We calculated in kilowatt. So here we see Exergy calculation is the physical Exergy. It has nothing to do with the chemical part. Obviously we need to calculate chemical part by using Excel and taking physical Exergy from here. So I will copy these values to Excel and calculate chemical Exergy. So by using these formulas and calculate chemical Exergy, uh, uh, copy these values and paste on Excel and apply these formulas and calculate chemical Exergy, Exergy destruction out, Exergy efficient, percentage Exergy efficiency, chemical Exergy. Okay, this is my final result. Physical Exergy in kilowatt mole flow rate. We know mole fraction is our one. For water we calculated also, and first total Exergy, chemical Exergy, total Exergy in, total Exergy out, Exergy efficiency.